Okay, so we're doing some Khan Academy exercises. They're wanting us to determine, you know, what are fair systems for deciding for making decisions, using probabilities to determining, what's fair. So here we go. We've got the scenario. It's recess and fourth graders. Sarah, Anna, Carlos, and Daniel arguing over who gets to use the tire swing. Only one person can fit on the swing. You figure out a fair way of deciding who gets it. So we have the four of them, right? So maybe what I do is just draw. Let's see if I can draw somewhere. Where do I get the draw? Okay. Boy, there's not a lot of drawing room here. We have right here above here. I'm gonna write. This is Carlos, and this one here will be Daniel, and this one will be Sarah, and that one will be Anna. So let's go through these like one at a time and see what they suggest and think about what the probabilities would be. So the first one says, Sarah says, let's flip a coin. Sarah suggests. Heads, I get the swing. Tails, Daniel gets it. So what are the outcomes that we'd have? Well, Sarah has a 1/2 outcome. And Daniel has a 1/2 outcome probability, right? There is no probability for Carlos or Anna, so I think it's pretty obvious that this one gets the scratch. This one is definitely not a fair system, so we're not going to check it. Okay? All right, let's start again here. Let's see if I can just erase just that part there. Oh boy. And this part there. All right, well, we'll just try that. Here we go. The next one. Carlos pulls out a nickel, a dime, and a penny. Throw all of them in the air. If they are all heads, Sarah gets the swing. If there are two heads, Anna gets the swing. If there's one head, I get the swing. If there are no heads, Daniel gets the swings. Okay, so we got a nickel. Let's draw a little table here, right? We can maybe draw it right. Oh boy, let me get my pen back. Okay, we can maybe draw right here. We have a nickel, a dime, and a penny. Right? Isn't that what it said? A nickel, dime, and penny. Yeah. And basically, in our sample space, right, we either have tails or heads. Okay? So these are the possible outcomes, right? We could get tails or heads for either one of these. So this could come up. We could get, let's see, what's the best table for this actually? We could end up, actually, you know what I'll do? Let's erase some of that. Okay, so we could get, let's try this. We could get tails, 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 right? We could get heads, tails, tails, heads, heads, tails, and we could get heads, 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 right? You know, probably the better system for drawing this out is, let's consider how many scenarios where we would get three. Let's do this the way we were doing the other problem. Let's think of the scenarios whereby we could get three heads. Well, there's only one, and that's that they all come up heads. So this would represent the one scenario under which, if they're all heads, Sarah. So Sarah's going to have one possible way to win, right? Now what about two heads? So how could we get two heads? Well, you could get tail, heads, head. You could get heads, tail, heads. And you get heads, heads, tails. So under those scenarios, that's the tail. You know, if there's going to be a tail, it has to be in one of those three positions. That's it, really. So, so Sarah gets the swing if there are two heads. So Sarah has, oh, I'm sorry. If they're all heads, Sarah gets the swing. So that was one. If there are two heads, Anna gets the swing. So Anna has three ways to get the heads. I think you can see where this is going, right? We could have one head, right? And in that case, we'd have tail, tail, head. I'm just going to alternate the position for the head, tail, tail, and head, tail, tail. So those are the only places, you know, if there's going to be one head, it has to be either here, here, or there. So who wins with the one head? If there's one head, I get the swing, and that's Carlos speaking. So he has 3 ways of winning. And there are no heads, so now we go with 0 heads, which means that they were all tails, right? There's only one way to get 0 heads, and that's for all tails. So clearly you can see 3, 6, 7, 8. There are 8 total ways, and Carlos gets 3/8, Anna gets 3/8, Sarah gets 1/8, and Daniel gets 1/8. Clearly not fair. So we will rule out the second one. That's not going to be a fair one. Okay, let's look at the next suggestion. So the next suggestion says, Anna says, Sarah and I will flip a coin. Carlos and Daniel will flip a coin. The winners of each coin flip will face each other in a final coin flip. So in the beginning, everybody has a 1/2 chance, right? Right? Each one of them has a 1/2 chance of winning. And then if they lose, we would eliminate 2 of them, and these guys would go again, and they would each have 1/2 again. Boy, that just sure seems fair, right? So that the person that wins has a 1 in 4 chance, 1/2 of 1/2, right? 1/4. So I'd say that's definitely a fair shot. There's no bias in here. These guys flip a coin, those guys flip a coin, winners advance and flip a coin. So that one looks very fair to me. The probability is 1/2 all the way through. Let's just flip 2 coins, Daniel suggests, a quarter and a penny. Both are heads, I get the swings. Both are tails, Sarah gets the swing. Quarter is heads, penny tail, Sarah gets the swing. Okay, so let's draw that out. Here's the options if we just throw a single time a quarter and a penny. Okay, so we have that the quarter could be, let's try getting rid of that. Let's say that the quarter came up heads, the penny came up heads. Or the quarter came up heads, and the penny came up tails. Or the quarter came up tails, and the penny came up heads. Or the quarter came up tails, and the penny came up tails. There's no other options than that, right? Either heads or tails. And then if this is one of them, the other one. So the combinations, there's only 4 combinations. In this case, if they're both heads, Daniel. So Daniel gets 1 of the 4. So Daniel's probability of winning is 1 of 4. Okay. Both tails, Sarah. So Sarah gets both tails. That's 1 event that event represents 1 out of 4 in the set again. So Sarah also gets 1 out of 4. If the quarter is head and the penny is tails, Anna, so here we go with Anna over here, she gets 1 of the 4, right, outcomes. And if the quarter is tails and the penny is heads, and that's Carlos. And so now I see this one as also everybody has the same probability. See, all we're really doing is thinking of ways that we can measure probability and comparing them. We want to see the same probability as we look at them. That's really what this is all about. Okay? Let me do one more problem. That was a 9-minute problem, so let's try another one real quick. Here we go. Margaret, Kristen, and Karen are taking a road trip. They're arguing over what CD to play. Margaret wants to listen to Alter Quick. Kristen, Two Paths, and Karen wants Gustin Fever. In order, it's not Justin Fever, is it? Okay. Gustin Fever. In order to make a decision, the girls are going to turn on the radio. They will listen to the CD of the first of these artists that they hear. Which station should they put on? To decide this, they put their identically shaped but different colored gum wrappers in a bag. Then Margaret will blindly choose one. So So what they're saying is that there's no way to distinguish. There's no bias for Margaret. They all look the same, and then the outcomes, will determine which of the three radio stations. So there's going to be a 1/3 probability that this comes out, a 1/3 probability that this comes out, and a 1/3 probability that this one comes out. So guess what? That works out pretty even, doesn't it? That works out even. As far as I can see, the method for choosing the radio station is unbiased, and the probabilities are even. Okay, so far so good through here. Now, the table tells us how many times each artist has been played. So here we have a scenario where the Alter Quick has a 2/3 probability. This has a 0/3 probability, and this one has a 1/3 oh boy, can't do that here. What's that? 1/3 for this guy. Man, I guess they don't like me writing below a certain level on these. So, but this one is a 1/3 right here, okay? And how about this? This is 2/9, right? This would be 2/9. This one would be 5/9. And this one would be 2/9 as well. Now over here we have 2/9. And this one is 3/9. And the last one would be 4/9. So now the question is, are the probabilities fair? So the way we do that is we would multiply each probability given A. This is a B given A, and assuming that A gets done, what is the probability of each of these coming out? So for Alter Quick, let's do A. Oh, that's not bright enough for me to really see. So let's try this again. Let's take the purple. So there's Alter Quick, right? That's this guy. So it's got a 1/3 times 2/3. So it's got a 2/9 chance of this outcome happening, right? Two Paths has a 0/9 chance because it is 0 times 1/3, right? So it's just a 0 chance. And then what do we have? Two Paths has a 1/3 times 1/3. So, oh, I'm sorry, that's Gust and Fever. So G has a 1/9. That was figured by taking 1/3 of 1/3, right? So that's a 1/9 probability. Let's add in the next probability of the other event. Here we have 1/3 of 2/9. So that's 2/27. And then this is 1/3 of 5/9. So that is going to be 5/27. And then 1/3 of 2/9, which is 2/27. Then we just do the same thing here for this. So we have two more 27ths. And 1/3 times 3/9 is 3/27. And 1/3 times 4/9 is 4/27. So now we just add these up, and we're going to have to triple the numerator and denominator here so that we have a common denominator. So this would be 6/27 plus 2 plus 2. That is 10. This one would have a 10/27 probability. That's a 10. Okay. This one would have 0 plus 5 plus 3. Okay, I can see that it's not fair, but this would be 8/27, right? And this one would be 1 plus 2 plus 4. It's 3. Oh, I'm sorry. We need to triple this. 3 plus 2. That's 5 plus 4. This is 9/27. Or basically 1/3. So this one is slightly better chance the alter quick, slightly lesser chance the two paths. So here we go. Is this method a fair way of deciding? No. What is the probability they listen to a CD of alter quick? 10/27. That's how that's done. Okay? Go ahead and get this exercise done.